So first, what is the direction of friction? I think it should be limiting, no? It should not slip means, okay, the most we can go for limiting friction. Then there's a normal contact, there's a weight, mg, there's applied force. Applied force given, it's just like a, we are holding it and we are going to rotate. So what is the possible value of mu? Is it data sufficient with this much? That's what we are going to ask also. Okay, let's see. We'll proceed. So what is needed now? The mu. This is theta and this is applied force. Let's get into, there's a point P or O, you write it. There's a center of mass, there's a point T. I'll proceed like this. So F cos theta plus N should be equal to mg. Then F sin theta should be equal to FL. Or time being, I'll write F. Later on we'll see what I can do with that also. I'll go for, this is net force along y-axis 0. It's a, the moment it's of equilibrium. So when at an angle theta, I am discussing about this. It is slowly. It's not going to accelerate. That's why I'm able to write it. If it's something accelerates, no, then we cannot write it. Slowly I'm moving. So still I can equate net force along x along y 0. Let me define net torque about 0.2. As I'm going to move it slowly, no. So F into L clockwise plus mg L by 2 cos theta. This will be clockwise, this will be anti-clockwise, equal to 0. So therefore this F equal to mg by 2 cos theta.
Sir, in the second equation, it should be capital F sin theta, sir.
Symbol. Okay, yeah. Okay, yeah, fine. Thank you. Capital F, no? Yeah, yeah. Okay, I have this one. So somehow that mu is what needed, no? Now, when do rod will start? When this point O will be fixed, I think this condition is what I'll highlight it. Without any slipping of bottom end. I think this particular question mark is there. No, let me read and think. So will this help me anywhere in taking any decisions? Position without any slipping of the bottom end. Bottom end means the O. O should remain fixed here. O. Don't say fixed here. Should not shift. So for that, what is the condition I should write? Definitely the friction force which is acting should be equal to what? Less than F sin theta. Then only possible, no? For point O, for bottom end O, not to shift, the friction should be less than or equal to F sin theta, you write it. What is F? F should be equal to mu Sn less than. The limiting friction should be less than F sin theta.
Less, sir. Greater now, sir.
If it is greater, slipping will occur, no? Friction should not be greater than limiting friction. Am I right?
Limiting friction should be greater than the F sine theta force mass. Then static friction will start.
See, the frictional force which is acting, if it is less than limiting, okay, no, because the static friction now it's there, it can adjust this particular value. But if it this F sine theta becomes greater than this limiting friction, slipping will occur no at point 2. So therefore the limiting friction should be less than F sine theta. Am I right? See, this force should be F sine theta should be greater than F for it to shift. For not to shift, the friction should be less than F sine theta. Mu s or mu k, or write only mu s if you're getting confusion. Okay, let it be, no problem. Mu, no. Because they didn't mention anything, so I'll write only mu. This is F sine theta, so mu. What is n? N is equal to mg minus f cos theta, right? What is f? We can write it as okay. I think I'll go for one more step here. F we have mg cos theta by 2, no? N I can write mg minus f cos theta. I think there's a better thing. Mg minus f cos theta less than or equal to f sine theta. Let me substitute the value of f, mg by 2 cos theta. Mg will get mg by 2 will get cancelled. So cos theta sine theta 2 minus cos square theta. What shall I do here? D mu by d theta. Let me differentiate and equate to 0. Anybody value of mu? Theta? We'll substitute that value of theta. Anything the value of mu less than that, okay, slipping will not occur at point 2. Answers given 0.4, 0.5. So maybe some, because less than is coming, any value less than that particular thing, okay, we can pick up that options. Anybody value theta? Theta, or directly give me value of mu. That will be sufficient. Anybody just hurry up, value of mu. I think all of you can hear me, no? Value of mu.
Sir, tan theta equal to 1 by root 2, sir.
Okay, tan theta equal to 1 by root 2. 0.707 or 0.71 will write it. So I need
1 by 2 root 2, sure. Mu should be less than or equal to 1 by 2 root
1 by 2 root 2. Mu should be tan theta. This is correct.
2. Yes, sir. Tan theta equal to 1 by root 2.
So mu should be less than or equal to 1 by 2 root 2. 0. 1 by root 2.
0.35 like that.
U should be 0.35.
Should be greater, sir. That only I'm saying. F should be greater than equal to F sine theta. The value got F was static friction now, sir. That F should be less than limiting friction value. It should be F should be FL should be greater than or equal to F sine theta.
Then we'll get some values. The friction should be, it should be sufficient. No? Okay, fine. Got it. I just made correction. It should be anything greater than this. Okay, that it should be not to slip here discussing. So anything more than this, is the rod workman will not shift. Is it irrespective of F? Can we justify our answer irrespective of value of F? Yes, if mu is greater than, so mu is 0.4 or 0.5, 0.6, irrespective of value. But it should not be such that it should, you can lift it up. Huh? There's also one problem with it.
It should be less than mg by 2 now.
That one. If it is greater than this, you may lift it up. Voice is okay. Now I think, can you hear me?
Yes, sir.
Okay, little bit I got confused. This condition is, I think, very important because either we may take wrong values also. It should not shift. The friction should be sufficient, no? So we'll put this condition. Okay, I'll take the next question. Yeah.